All right, so we talked about arithmetic sequences. Well, we talked about general sequences. Then we talked about arithmetic, and now we're talking about geometric sequences. Geometric sequences are one in which the ratio of consecutive numbers are the same. So we know arithmetic is the same number being added. The common difference would be the same. Now it's the same number basically being multiplied by each term in each consecutive term in the sequence. So the sequence a sub 1, a sub 2, a sub 3, a sub 4, all the way to a sub n is geometric when there's a number, and we call this variable r for common ratio, such that if I divide the second term by the first, divide the third by the second, the fourth by the third, I end up with the same ratio. So again, this variable is r, and it stands for the common ratio. So we've got common difference for arithmetic and common ratio for geometric. All right, so example 1 says determine whether or not the sequence is geometric. So sometimes they're going to be obvious. You can just look at the second, divide it in your head by the first, third by the second, and make sure they're all the same. So 12 divided by 3 is what? 4. 48 divided by 12 is 4. 192 divided by 48 is 4. So this is yes, this is a geometric sequence, and the r would be 4. Sometimes it's not as obvious, so maybe with b, we've got to try it out. So I would take 1/2 and divide it by 1, which is 1/2 times 1, 1/2. And then I would take 1/3, divide it by, that's a divided by, divide it by 1/2, that becomes 1/3 times 2, and that's 2/3. As soon as you get one that doesn't match, you know this is a no, this is not a geometric sequence. So the question might now come, is it arithmetic? If not, is it geometric? And then if not, state no. So you might get them combined into one. Obviously, by the time we get to the test, they're both going to be on there. Okay, example 2 says write the first 5 terms of the geometric sequence. So again, if we compare this to arithmetic, with arithmetic, we would add d on every time, right? What would you do with geometric? Multiply. So you're going to take 1, multiply it times 1/2, and I get 1/2. That's a sub 2. And then I would take 2 and multiply it times 1/2, and I get 1. That's a sub, wait, just kidding. Hang on. I already did 1. 1/2. 1/2 times 1/2, 1/4. This is a sub 2, this is a sub 3, and then 1/4 times 1/2, which is 1/8. That's a sub 4, and then 1/8 times 1/2, 1/16. That's a sub 5. So when I list all of my 5 terms, I will start with 1, then 1/2, then 1/4, then 1/8, then 1/16. Questions on that one? Okay, example 3 says find the nth term of the geometric sequence has the form a sub n equals a sub 1 times r to the n minus 1. So just like we have a formula to find the equation of a sub n if it's arithmetic, you now have a formula to find a sub n if it's geometric. So we still start with a sub 1, but then we multiply it times r to the n minus 1. So this is the third formula you need to know for the chapter. All right, example 3. Wait, this is the second example 3. So this example 4 says write the first 5 terms of the geometric sequence, find the common ratio, and then write the nth term of the sequence as a function of n. So you start, there's 3 parts to this. Find the first 5 terms of the sequence, then figure out the common ratio, and then figure out the equation for a sub n. All right, so first 5 terms in the sequence. This is a recursive one, right? So I would take 9 and I would multiply by 2, get 18. Take 18, multiply by 2, get 36. 36, multiply by 2, get 72. 72 times 2, 144. So the first 5 terms in the sequence are 9, because that's the first one they gave me. 9, 18, 36, 72, and 144. What's the common ratio? 2. It's what I'm multiplying by every time, right? And then it says write the nth term of the sequence as a function of n. So hopefully we're learning that those words mean give me the equation that would give me a sub n. So a sub n equals a sub 1 times r to the n minus 1. A sub n would equal my first term, which is 9, times r to the n minus 1. So pay attention to the order of operations here. That exponent is on what term? R. So when I rewrite this as a sub n equals 9 times 2 to the n minus 1, 2 is what gets that n minus 1. Okay, there's a question like this on your quiz yesterday, and some of you multiplied before you raised to a power. The exponent comes first. So that exponent is only on that base, which is the 2. You would raise that to a power before multiplying by 9. So this is writing a sub n, writing the nth term of the sequence as a function of n. Okay, that's what it means. It means give me the equation.
Does it matter if you put the exponent outside the parentheses?
No, as long as you don't group the 9 and the 2 together. So if you rewrote it as a sub n equals 9 like this, 2n minus 1, that's still fine. As long as you don't put the parentheses around the 9 and the 2, then it's wrong, right? Because then you're doing 18 to the power. Questions on that one? Christine? So this one actually has multiple parts. So this would be the 5 terms, what is r, and what is the equation, that last one where you would replace the r with the 2. All right, number 4 says find the formula for the nth term of the geometric sequence, then find the indicated term of the geometric sequence. So the first thing it gives you is a series of 3 to 36, 36 to 432. You can use your calculator on these. They're going to get to be large, okay? I would stick to scientific, okay? I will let you know for sure next week what you're going to be able to use, but I would stick to scientific as you're getting used to it, obviously graphing to check them. So 36 divided by 3 is what? 12. And then 432 divided by 36 is also 12. So I know r is 12, which means the equation is a sub n equals a sub 1, which is 3, times r, which is 12, to the n minus 1. Then it says, find the 7th term. So I'm finding a sub n, which would equal 3 times 12 to the 7 minus 1. And this should be a sub 7. So the first thing I would do is do 12 to the 6th power, which is 2,985,984. And then multiply that times 3. So find the formula, and then find the 7th term. Questions on that one? Okay, example 5 says find the indicated term of the geometric sequence. So this time I know a sub 1, I know a sub 4, and what I'm looking for is the 10th term. So what I don't know this time is the common ratio, right? But if I'm given these two, if I'm given a sub 1 and a sub 4, then I can rewrite a sub n equals a sub 1 r to the n minus 1 as a sub 4 equals a sub 1 r So if I'm in the fourth term, what's n? 4 minus 1. And I know a sub 4 and a sub 1, so I still have a 1 unknown this way. So a sub 4 is 1/2. A sub 1 is negative 4. R is what I don't know, but it's raised to the third power. So how can I solve for R? Divide by 4 on both sides, negative 4. Yeah. So it's being multiplied by negative 1/4, that's 1/8, equals R to the third. And then? Negative 1/8, yes, thank you. Negative 1/8 equals R to the third. And then what? Cube root it. So the cube root of negative 1/8 would be what? Negative 1/2. That's your R. So that gets us what we need in order to find the equation, which will get us to the 10th term, which is our goal. So I would say if it's only asking for the 5th term or even the 6th term, you can take a sub 4 now and multiply it times R once or twice, whatever it is. But if I'm jumping all the way to the 10th term, I don't want to have to go from 4 to 6 to 7 to 8 to 9 to 10. So I want to figure out what the equation is. So a sub n equals a sub 1 R n minus 1. A sub n is what we're looking for. That's the 10th term. A sub 1 is negative 4. R we now know is negative 1/2. And the 10th term would be 10, and I'd subtract the 1. So a sub 10 equals negative 4 times negative 1/2 to the 9th power. And you want to keep this in fraction form. So 2 to the 9th is 5/12. A sub 10 would equal negative 4 times a negative 1 over 5/12. And then simplify it. I'd get a sub 10 equals a negative times a negative, which is a positive, and 4 goes into 5/12 128 times. So you have to use the information that they give you to find what R is. And then establish your a sub n function and then plug in the information and look for what you're looking for. Sarah.
How is the 1 over 5/12?
Because it's to the 9th power. So a negative times a negative times a negative and not an odd number of times is going to result in a negative.
Where does the negative come from?
The negative 1/2 is my R. So over here, I found R, right? So the negative sticks with it. If it was an even power, it'd go away. If it was an odd number, it's going to stay. Questions on that one? All right, find the indicated term of the geometric sequence. So try it now yourself. This time you have a sub 2. Actually, I'll help you with this because there's a little bit of a trick. A sub 2 to a sub 5, and I want to find the 6th term. So think about what happens every time I want to find a sub n. So if I write this out, Rn minus 1. If I'm looking for, let's say I'm looking for a sub 6, what would R have to be raised to? It's 5. If I'm looking for a sub 2, what is R being raised to? 1. A sub 3, 2. They're always 1 apart. Does this make sense? So if I'm looking for a sub 5, if I have a sub 5 and a sub 2, I'm always going to put the larger one on the left. So let's say I have a sub 5 over here. And then let's say I have a sub 2 instead of a sub 1, because I don't know what a sub 1 is. Then the exponent on my R should be the difference between the left and the right. So think about if I'm doing a sub 2, I would do a sub 1 R to the first, right? Because it would be, you with me? It would be 2 minus 1, which is 1. So the exponent on the r always makes up the difference between the number on the left and the number on the right. So you can actually change it. I don't always have to have a sub 1. If I want to find the equation, the general equation for a sub n, I need a sub 1. Like if I'm asking you for the nth term in terms of n, then you're writing it to me in terms of a sub 1. But if you are using it to find an indicated term like this, you don't have to go all the way back to a sub 1. You can just make the difference up with what you raise r to. So if I have a to the 5th on the left, then that means I would use a to the, whatever I have, which is a to the 2nd on the right, and then I would raise r to the power that is the difference of those two. So for this one, I'm going to use a sub 5 on the left, which is 2/3, equals a sub 2, which is negative 18, times r to the 3rd. And then I want to solve for r. So I'm going to divide both sides by negative 18, which is multiplying by 1/18, negative 1/18. This is negative 1/27. And then I would cube root both sides. And r equals negative 1/3. You with me so far? So now I can create my equation. I can actually go backwards from a sub 2. Instead of multiplying by a negative 1/3, I would divide to go back to a sub 1. Or I can do what we just did with a sub 5 on the left, a sub 6 on the left and a sub 5 on the right, which would look like this. So I'm looking for the 6th term, which means I can multiply the 5th term times r to what power? The first power. Remember, the exponent on the r and the base on the one on the right has to add up to the one on the left. So a sub 6 is what we're looking for. A sub 5 we know is 2/3. And r to the first would be negative 1/3. So a sub 6 would be a negative 2/9. Okay, so we had the finite of the arithmetic sequence. Now we're talking about the sum, of a finite arithmetic sequence. Now we're talking about the sum of a finite geometric sequence. So this is like finding the sum of a specific amount of terms in a geometric sequence. So if I had I is 1 on the bottom and on the top I had 10, I could literally take 1, plug it in, 2, plug it in, 3, plug it in, all the way up to 10 and add them up. Or I could use this formula, which says that a sub 1 times 1 minus r to the n over 1 minus r. So this is what your function's going to look like. Well, some of them. We'll give it to you in summation form. So it's going to have the little sigma. The number at the bottom is your initial term. The number at the top is your n. And then it should be in the format in which a is a function of n, meaning a sub 1 times r to the I minus 1. From that, you can pull out your a sub 1. You can pull out your r, and the n is from the top. And then just plug it in. It's a sub 1 times 1 minus r to the n over 1 minus r. So this is now what formula 4 that you've got to memorize for this chapter. And the common ratio can't be 1 here in order to do this. All right, so it says find the sum. It's not as bad.
Are you sure?
Yeah, take a deep breath. It's okay. So the first thing you should identify is this is not an arithmetic one, right? I'm not adding the same thing to every term. Does everybody recognize that? It is geometric because I am raising, like I have a to sub 1 times r to the n minus 1 in the top. Okay, that's how you can identify that it's geometric. So from here, the sum would equal a sub 1 times 1 minus r to the n over 1 minus r. So I have 3 parts I have to identify. The a sub 1, the r, and the n. What is a sub 1?
Oh, you plug it into the formula?
Oh, you don't even need to.
Because isn't it raised to 0?
Because what's going to happen if I start at 1? It's raised to the 0 power. What is anything to the 0 power? 1. 1 times, what's my a sub 1? 32. So the a sub 1 is already in the equation for me. I don't even have to find it. Could you? Sure, if you forget how to do it. But you don't need to. You're always going to get 0 on the exponent. That goes to 1, and then that gets multiplied by a sub 1. So the a sub 1 is already in the equation. A sub 1 is 32. It's the one that is not being raised to the power.
So anytime it's to the 1, it's going to be the number being multiplied, or is it just in this equation?
Anytime it's to the 1. So that again.
Like when it's 1 minus 1, anything raised to the 0
is
becomes
1. And then you'd multiply it times a sub 1. Yep.
So you'd get 32 as like the
Yeah,
a sub 1.
which is your a sub 1. That's why, so I have the a sub 1. The next thing I need is the r, and the r is the thing that's being raised to the power. So the r is the 1/4. And the last thing I need is the n, which is at the top. If it's 1 on the bottom, remember 1 to 6, that means that the top is it. If the 1 was not on the bottom, then my number changes. And now I just plug it in. So I get a sub 1, which is 32, times 1 minus 1/4 raised to the 6th power over 1 minus 1/4. So then I get 32. Again, you'll have a scientific calculator for something like this, but I want you to keep it in fraction format. I don't want a decimal that's rounded. I want this kept exact. So 4 to the 6th power is 4,096. This would be 1 over 4,096 over 1 minus 1/4. And then I've got a complex fraction. I've got a fraction within a fraction. I have to eliminate it. First thing I want to do is combine these two into 1. So I have to change 1 to be what? 4,096 over 4,096. So it's 32 times my numerator is 4,095 over 4,096. My denominator, this becomes 4 over 4 minus 4 over 4, which is 3/4. And then I want to keep, change, flip. 4,096 divided by 4 is 1,024. And 4,095 divided by 3 is 1,365. So I still have 32 on the outside, but inside is now 1,365 over 1,024. And then 32 goes into that 32 times, and I get 1,365 over 32. So what?
Sorry, my question was like, what was like
The n.
to like, yeah, to exactly.
So if it was 2 on the bottom, because it's going to affect two ways, right? So I equals 2, 32, 1/4, I minus 1. Okay, if it is not 1 on the bottom, then not only does it affect your a sub 1, okay, so I'd have to know what, well actually no, it's still the same thing. This is still your r, right? What the difference is the a sub 1 here. You would have to take the 2 and plug it in to get what a sub 1 is. And then your n would also get adjusted. So remember, it's top minus bottom plus 1. So it would be 6 minus 2, which is 4 plus 1, which means your n would be 5. So I don't think that's, I think in the homework it's 1 on the bottom, but I'll check. But if it's not, if you see it where it's not 1, then you'd have to find your a sub 1 by plugging in, because your a sub 1 is really a sub 2. It's your initial term, that's what it is. And if the bottom is not 1, then that is your initial term. You'd have to plug that in to get the a sub 1, and then do your n by doing the top number minus the bottom number plus 1. Okay, so then this one, use summation notation to write the sum. So the same result, I want the sum at the end, but it's telling me to use it in summation notation. So the summation notation is this. So a sub 1, r to the n minus 1, and then your n at the top. So that's all the pieces of the summation notation I would have to plug in. What of that do you already know?
A sub 1.
I know a sub 1 is what? 7. So this is my a sub 1. 1. This is 7. Do I know what r is? It's 2. Not right off the bat, like it's not blatantly given to you, but I know that this is going up by multiples of 2. So r is 2. So what's the one piece of information I don't know? The n. I don't know how many numbers it took me to get from 28 to 896. I could take 896 and divide it by 2 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 until I hit 20, until I hit 7, and that's my n. Okay, but the bigger the number, the harder that is, which is why I'll go back to the nth term equation to figure it out. So I know that if I'm doing a sub n equals a sub 1 r to the n minus 1, the a sub n in this case is the last one. We know that that's 896. The a sub 1 we also know is 7. The r we know is 2. What we don't know is the n for the n minus 1. So how do I work backwards to solve this for n? Divide by 7. So that's 128, right? 128. And then this goes back to your exponents and your logs. So you could actually ln both sides of that, flip the exponent to the front, or you could change the base. So 2 to what power is 128? 7th. So I could rewrite that as 2 to the 7th equals 2 to the n minus 1. And then my n minus 1 equals 7, and n equals 8. Now I know the n at the top here. You with me so far? This is as complicated, I think, as it gets. Because you have parts of the information, you got to figure out how to get the other part. Okay? The rest of them are straight up formulas. But just think about, like, if I'm going to write summation notation, think about what you have, think about what you're missing, God bless you, and think about how you could find it.
If we wouldn't have divided 7 and like multiply, would you be able to multiply 7 times 2?
It gives you the wrong answer.
Okay.
So you got to do the exponent is only attached to the 2.
Okay.
Come on.
How would we have done it with the ln?
You ln on both sides of the equations. The exponent from the n minus 1 goes to the front. You would divide ln of 2 by ln of 128. And then you'd be left with your exponent. All right, so now it said use summation notation to write the sum. I just got the summation notation, which is here. Now I need to find the actual sum. So the sum is a sub 1 times 1 minus r to the n over 1 minus r. A sub 1 we said was 7. 1 minus r, which is 2. N, which we said is 8, over 1 minus 2. What is 2 to the 8th? 256, right? Yeah, 256 over 1 minus 2. 7, negative 255 over negative 1. 7 times positive 255. 1785. Questions on that one? Yep.
So I just assume it's 1.
So if you're writing the summation notation, the default is 1. Yeah, like you assume it's 1 unless it's changed.
Okay.
Just like when you're starting to figure out your series of terms, you always start with 1 unless they tell you something different. Yeah. Questions on that one? Okay, then in this section is the sum of an infinite geometric sequence. So this is now your 5th equation. What does infinite mean? It never ends. So this is how you would find it if the n was infinity. Notice the little infinity symbol at the top here, okay? What's crazy is the infinite one's probably the easiest one. It is a sub 1 over 1 minus r. That's it. Now this only works if the absolute value of r is less than 1. So that means if I ignore the sign on the r, because that's what the absolute value means, less than 1 would look like what? A fraction or a decimal that's not improper if it's a fraction, right? So I can't do this if r is 3/2. Doesn't work. But if it's 1/2, if it's 3/4, if it's 7/8, anything like that, it works. If it's negative 7/8, it's fine. You ignore the negative. And if it's a decimal that's less than 1, again, totally fine. Okay, that's when this works. So you have to notice the differences between this formula. What is the difference between the summation here and the summation on the last one? Infinity's at the top, and I is 0. And if that's the case, then look what's happening over here. I is not -1. Remember, it was I -1 before? So it's already shifted. The bottom shifted, which means the exponent shifted. So the homework I gave you only zeros on the bottom. Should you see something with a 1 on the bottom, then you would see the exponent on the R as I -1. It adjusts. Okay, it's not like it's tricky. It's going to adjust for you. But again, this is infinite at the top. The a sub 1 comes from the 1 is not raised to a power. The R is the one that's raised to the power. Those are the only two things you need out of summation for infinity. And it's a sub 1 over 1 minus R. So it says find the sum of the infinite geometric series if possible, and if not possible, explain why. So the first thing we're doing is seeing if it's even possible. And to do that, we look at what? The R. Is the absolute value of R less than 1? Yes. R is what in this case? Negative 1/2, right? Absolute value would be 1/2. 1/2 is less than 1. What is a sub 1? 5. And then the infinite sum would be 5 over 1 minus a negative 1/2, which becomes 1 plus 1/2. And I get 5 over 3/2. Keep, change, flip. And I get 10 over 3. And again, you'll give it to me as a fraction in simplified form, not a rounded decimal. Easiest for last, right?